What's up, guys? Y'all thought y'all gonna get away from me that easy? You think must be kidding yourselves. Alright, so what y'all gonna talk about today? Well, I'm not in the classroom, still here. Alright, multiple representations of exponential functions, okay? So we know multiple representations are basically talking about tables, equations, describing different characteristics that we know exponential functions have. Okay? Alright, so let's do this first two together, and we might do number three, depending on how I'm feeling. Kind of tired right now. Alright, but, so we have these two. Find the characteristics of each function. Now, you know how to do this, okay, with the graph. But in this case, where you have a table too. So, we're still not going to let anything fool us. First, we want to figure out, guys, what type of equation is number one. Looking at this, just by looking at the y values, I know it's doing what I'm looking at. Okay, first, we know they're not adding. So we know it's not a linear function. So what the function I've been talking about? We're talking about exponential function. So I know it's an exponential function. The equation to find the exponential function is always y is equal to a times b to the x. What's my first value? Which is a. Looking at this, we know it's always my y-intercept. I use the y, so my equation would be y is equal to a is equal to 1. What's my rate? What is it being multiplied each time by, guys? You're correct. It is 3. Okay? Alright, so now we have that. Keep my x up here. The domain. Domain never changes, guys. You know, the domain is always negative infinity to positive infinity. Yeah, I can do that pretty good on this iPad. Alright, now let's look at the range. Range, talking about my y values. We know the range is coming from the asymptote to infinity or negative infinity. How do we know that? We have to check this out. What's my asymptote? By looking at this equation, do you see anything behind the equation right here? Let me see if I can kind of give you another color. Looking right here, it's nothing back here, right? We know if you don't see anything, it's always plus 0. So your asymptote is 0. So we know if we have the asymptote is 0, we know our range is going to start at 0. Now, let's look at the graph. Is it increasing or decreasing? My graph is increasing, so I know it's going to positive infinity. The way I know it's increasing because I'm looking at these numbers here. They're doing what? Getting larger. Okay, x-intercept. Let's look at this. Do you see any points on there that give me x-intercept? No. So, of course, that's none. Haha, though. What's my y-intercept? My y-intercept is always 0y. So if I'm looking at this table, I know my y-intercept will be 0, 1. We already answered this. Is it increasing or decreasing, guys? We know it's doing what? Increasing. Okay? Alright, so now that you guys had it down in your paper, let's take a look at the next one. Now, something a little different. What's the equation? Let's look at this again. Exponential function, because we know a linear function always looks like a straight line. This one doesn't look like that. It looks like a what? Curve. So we know that's exponential. Alright, so let's check this out. Go ahead and get through this so you guys get to working. Alright, so the equation we know is always, again, y equals a plus b. I mean, not a plus b. Y equals a times b to the x. Now, what's my first value? Let's look at the what? Y-intercept. Where is it crossing the y-axis in? 0, 1. My first starting value will be what? 0. I'm sorry, not 0, 1, but just 1. Take the y value out of that. So y is equal to 1. Now it says something right here. It's helping us out. Each y value is half of the what? Previous y. So what's my rate? Yeah, you're right on that one. It is 1/2 or 0.5 to the x. Okay. All right, let's take down that. That don't look too good. All right, so domain again. What is it? Shantae, Sierra, keep talking in the back. Please quit talking in the back. All right. Chandrian said, quit all that. All right, so domain is negative infinity to positive infinity. All right. Xavier, quit laughing. All right, so now what's my range? Looking at my range, we know the asymptote is what, guys? 0 to infinity. Good job. What we also know is my x-intercept, does it have one? It's approaching the asymptote, which is y equal to 0, but it looks like it's touching, but it's actually not going to touch it or cross it, guys. So y-intercept for this one is none. What is my y-intercept? Again, is 0, 1. And my graph in this case is decreasing. So guys, looking at both of these representation of exponential functions, they both have the same what? Y-intercept. So looking at this right here, okay? One's increasing, one is decreasing, both have the same domain, okay? Now what difference do you see? This one's decreasing, y is decreasing because it has a fraction. All right, a fraction for my b. Over here we have a whole number, so my graph is increasing. Okay, just make sure you take a note on that because you'll be talking about transformations next week. All right, so let's get out of this. Boom, exit drawing. There we go. Okay, so let's look at the rate of change. Now, I'm not gonna go through that because you guys know how to find the rate of change. We know we're just gonna plug it into what formula? Y2. Oop, sorry, let me get back out of that. All you do, guys, is plug in y2 minus y1 over x2 minus x1. We know that. Okay, no need to keep going further with that one. All right. Now let's look at number 3. I'm going to go ahead and do it for you guys, okay? Help you out a little bit. But I'm going to give you some time to do it on your own. Miss Yamini, Miss Jones, Miss Campbell, can you guys go ahead and pause the video and let them do it on their own? Give them about 5 minutes. They should be able to do it. Alright, guys, so these are the answers right here. Try to do the best I can as writing it. But the equation we have is, you know, the first day they sold 2 hams, and then the rate is 4 because they sold 4 times as many as each day. Alright, it's discrete because, you know, you can't have 2.5 hams. You got 1 ham, 2 hams, 3 hams. So it's discrete in that, and that's why you don't see my connecting my my points, my coordinate points over here on the graph. All right, we know. Okay, I actually made a mistake right here. We know if it's discrete, we should always do what? List our domain and range. So in this case, I'm just going to list the 2 that are up here. We know we have our domain. We'll just say call it 0 because we'll start off with this as my y-intercept. 1 and 2. It's the only ones I can graph, and the range would be, what's that? 2, 8, and 32. Okay. Only because it's discrete, guys. We know if it was continuous, then it'd be what I had up there, which was negative infinity, positive infinity. All right, x-intercept doesn't have none. Y-intercept 0, 2. The graph is increasing, and this is my rate of change down here. Okay. All right. So good luck. You don't need it for today. Finish the rest of the work. You can work with a partner or whatnot, and make sure you turn the work in to Miss Jones or Miss Yamini by in the class. All right, guys. Talk to you later. Peace.